not
Are
ready.
we going to talk about robots? All right. Coming out, everybody. We are Reach Robotics and Carbon Robotics here to talk to you guys about robot arms, battle robots, the future of robotics, and how to survive when they come for you. So, there's no surviving.
I bow to the robot overlords.
We make good robots. So we're going to start off real quick with quick introductions, nothing too long. I'm going to start on my right here, your left, with Chris. You want to introduce yourself real quick?
Hi guys, I'm Chris from Reach Robotics. I'm the CTO from the UK, and we're making basically gaming robots. You guys have seen BattleBots. We're making the kind of desktop version that you can play in the kitchen and not set fire to the house. And that's us in a nutshell, really.
And on my left, your right, we have Carbon Robotics. Please introduce yourself.
Hi, I'm Rosanna. I am the co-founder and CEO of Carbon Robotics. We are building a robotic arm that has the capabilities of an industrial robot, but the price of a laptop. So it's really cool because you can physically guide it through a routine that it replays, so you don't actually have to know how to code to get started. But it's hackable depending on what you put on the end. It can be a 3D printer, it can be a 3D scanner. And then you can also make your custom end effectors as well, so you can make it do what you want. And this is my co-founder, Dan.
I'm Dan. I'm the CTO of Carbon Robotics. I do the exact same thing as Rosanna.
Most of the time.
So I'm going to do this a little bit different. I'm going to start with a quick lightning round so you get to know everybody. So first off, real quick, don't think too hard. Hometown.
Bristol.
Cambridge.
UK.
UK. Okay, Bristol, UK.
Cambridge, UK.
Cambridge, UK.
Boston, Massachusetts.
All right. Favorite video game? Go.
Fallout.
Portal.
Mass Effect.
Wow, they're quick. Nerdiest achievement?
Making a robot.
All right, that counts.
Can we use that one too?
No.
Okay, I was pretty proud of myself for getting to level 13 on Duck Hunt after N years of having not played.
I went to a photonics convention in a Aperture Science polo shirt, and when people asked me what I did, like what my company did, I said quantum tunneling.
We'll take it. He went. Dan wins. So let's talk a little bit about robot arms. Rosanna, Dan, your company built a robotic arm.
Mm-hmm.
Can you tell us a little bit about how that idea came about?
Yeah, so Dan and I went to university together, and so we worked on a number of projects together, and we had a lot of things that we sort of hacked together, and so we did a number of CNC conversions. We did a bunch of things that really would have benefited. A lot of people who go into robotics, I think, were probably had that at birth, that they were really excited by robots and robot arms. But as we were doing our projects, we realized that you really can't just buy a robot arm off the shelf. They're very, very expensive. They're $100,000 frequently, especially at that time, and they're really hard to program. And so we thought, you know what, between us, we've got a lot of the skills required to build this. So why don't we try and do that?
Yeah, a lot of it was after we'd seen the film Gravity, and if you've seen the movie, it's all shot with 3 industrial robotic arms, and they whip these cameras around and they whip Sandra Bullock around, and this was all done in a computer beforehand. They created a scene in Maya, and they had a virtual camera that would move through the scene, and then they export the virtual camera to the real world camera, and export the virtual Sandra Bullock to the real world Sandra Bullock, and that kind of blew our minds to seeing the creative potential for robotics in applications that would not have been automated beforehand. And we see all this talent out there, that people that know how to program, that are getting into making, that are building things, but might not have the degree in mechatronics you would need for robotics. And we want to be able to give those people a way to take that talent, take that inspiration, and move it into the real world.
So you talked a little bit about using this for videography and sort of do-it-yourself Gravity, the movie. What else do you see the arm being able to do?
Well, so out of the box, we have a number of attachments that we've built. So in a workshop, for instance, you can do 3D printing. We have sub-millimeter precision, a 1 kilogram payload. So it can actually do really, really cool, yeah. That was hard.
Sorry, engineer. Ignore me.
And so you can, because there are modular attachments, you can take that off, put a 3D scanner on the end, and it's 2 tools in one. But then you add laser cutting. We have an attachment for that, and then also foam milling, which is pretty cool. And in that sense, it's kind of like a KitchenAid for your workshop, is how we think about it. But the thing that we're really, really excited by is that, as Dan was saying, when you let people who are makers, who are builders, who are creatives, have access to technology, and they don't have to do the really, really hard electromechanical stuff, you get to see some really, really cool things. And so, like, one use case was recently somebody wanted to do cake decorating with a robotic arm, which is awesome, but we are not going to spend like a month building a cake decorating robot. But by building the platform, we let them do that, and that's really inspiring for us.
Yeah, we were like thinking like, what would it actually take to like make a CAD to cake package, and it was more than we wanted to spend.
Well, that sounds delicious, but let's switch over to gaming robots. Chris, how did you come up with the idea for gaming robots?
So we started out as a company doing what we thought was the coolest thing in the world to do, teach kids math, science, and engineering. And it turns out that is not the coolest thing in the world to do. As much as we want it to be, it's not. And kids just weren't really that impressed with the kind of kits that were out there. They put it together in 2 minutes, it was done, and that was it. And we then started trying to use toy robots basically to get them into robotics. And again, that was 2 minutes and it was done. And we then started making our own little bits of kind of robots, little toys and so on. And people were like, oh, these are cool. Can you do this? And we're like, well, in a couple of weeks maybe we can make it do this. And that kept snowballing and snowballing. And then suddenly, we started developing basically a gaming robot to teach maths and engineering. And this is where we got to now, where we're basically teaching kids to battle their robots. And to begin the robot uprising, I guess we'd start saying, see on the table.
Well, that's a good intro. Can you sort of give us a quick show, let us figure out how we might dodge this thing as it chases us down the street?
Yeah, surprise tech demo. That's always what I wanted. Thank you, Lewis.
No pressure.
No pressure. No worry either. It's not going to kill anyone today.
It is pointing outwards.
So the whole idea is with these guys, you control them with your phone. So this is connected onto my phone. We can do, I don't know if anyone can see, but we can do the skills. So the whole idea is it reacts, it does things. The other robot then reacts to this as well. And you battle them pretty much like the kind of big battle bots you see on TV right now, but kind of on our desktop. And that's it in a nutshell, really. You fight them just like any other kind of game. And we mix the kind of virtual and the physical into one.
Do the flamethrower.
Just like close it down. So the flamethrower, this kind of stuff, and I'll finish
Flame
it
sold
for everyone.
separately, so.
And then we just do the EMP just to ruin everyone's day, and that's pretty much it for the party.
But if a robot activates its own EMP, it destroys itself.
That
seems dangerous.
This is the last thing. Get it out your bag and holy hand grenade everyone, really.
Holy hand grenade, he says.
So let's take a step back. For everybody in the audience, if I wanted to get into robotics, how do I do that? Like, what's a path? What's a way? I mean, you guys all come from different backgrounds. How do you get into robotics?
Do you want to take this?
It starts with Legos. We are in a robotics accelerator, and there's 10 companies there. Every single person had a Lego room growing up.
Do you still have your Lego?
I still have
mine.
some.
Yeah, I think everyone in there still does.
Yeah, and
the
like
Lego.
occasionally, like people will build conceptual prototypes of them. That is, like the Lego people are absolute saints, and like if you're talking like if I could trace my path to robotics all the way back, Lego was the beginning. From there, it was programming, microcontrollers, electronics, and shop skills. And eventually that all kind of coalesces into STEM, and from there, robots.
I think what's interesting about that is that, so like, everyone started building with whatever tools that they had. It was just this kind of instinct and this drive. But something that's really cool, that's different now than when we were growing up, is that more and more you can do really cool high-level stuff without having to know all of that, without having to know how to program microcontrollers, without having to understand what's going on at a deeper level with the electronics or using shop tools. I mean, that's really cool and that's really, really fun, but more and more you can start as like, hey, I want to build an iPhone app, and then you hook that up to a fighting robot, or you hook it up to a robotic arm like we're building, and you are effectively becoming a roboticist, but you're really just an app developer. I mean, you're an app developer.
Yeah, and I guess the high street has made all this kind of possible. Places like Radio Shack and so on, which are now selling tiny little robot kits. Our first couple of prototypes actually got us funding and money, were literally made from Arduinos hacked together like everyone does, with some servos showing this is what we can do. And all of this was possible. We found this stuff on the internet basically, and although I've actually got a master's in robotics, this was all things you could find, easily set up, do, without much experience or needing to. It's just how creative you can be really is where it goes with that, I guess.
It is really nice to have technologies like the Arduino and other enabling things, because it lets you leapfrog a lot of the kind of slog that you'll get, dealing with how do you get a bare metal chip running code. Like, that is stuff that's not necessarily on the critical path to robotics, that is not necessarily something that you absolutely need to know to start moving things around in the real world. But without enabling technologies like the Arduino, you would have to learn all that and learn a lot of things which are not necessarily related to what you want to do. If you had to build a screwdriver every single time you wanted to put up a shelf or something, it'd be insane. And we're really excited to see more tools coming out that perform the same abstraction with robotics, that let you leapfrog the slog.
So if I'm a parent, for the parents out there, is there anything out there that you guys can think of that would be sort of a good entry point for kids? A great kit, or I don't know, give them a welding torch, something.
That's true.
Wait till they're 12.
Obviously, we mentioned Lego, Arduinos, Meccano, that kind of stuff. But if you go on eBay, you can buy for like $10 a random box of electronics, buy them a soldering iron, and just let them play in the garage for hours. Because chances are it's someone like me who's gone, oh, I have a random bunch of electronics into a box, and then I sell it off to people, and there's enough stuff in there generally to make a robot and so on. So I think that's the best thing to buy if you want someone to get into engineering. And Google, show them how to use Google.
I think that's a really good point that you bring up, which is that when people are builders and they're very creative, they're just going to use whatever's around the house. So have more stuff around the house.
And let them take it apart.
Oh.
Printers are filled with motors and gears and tiny pulleys. I have one friend who, like, his best mechatronics course, the professor had a room that was just old printers, ripped apart, and he said, go back in there and come out with a robot. The other thing I would really, really advocate is be involved with them. You can't just throw a kit at a kid and expect them to be excited about it at all. If you are taking something apart with them, if you're excited about something, if you're looking things up on the internet with your children, that's what instills that desire to learn and the desire to pull things apart and break things and build things of their own.
You might have to learn how to put them back together yourself at first.
But the more expensive it is, the more fun it is to put back together. There's that danger in putting it together.
So, gotta adjust this. So, Rosanna, Dan, you specifically started out as a software developer, and that followed her dream into robotics. How do you see software playing with hardware? What was that road that you took in?
I guess professionally before this, I was doing software development, app development. As Dan said, one of the kids who started with Lego. So I was always sort of putting things and hacking them together. But I think that the really, really cool thing that's happening more and more is because things like the Arduino, it's becoming really, really easy to affect, to work with sensors, to get data in the real world without actually having to build it yourself. And more people are sharing those. So like a big part of what we do is open source, and it's making sure that when you build an application, you can share that with people. You can share it with them as an app, or you can teach them how to do it. And so for us, we really see it as being that each person builds on each person. And I mean, at this point, you really don't have to like get into assembly to work with electronics, which is pretty cool.
Another really cool thing about software coupled with robotics is that software is one of the quickest paths from idea to something that has value in the real world. Maybe it's not in the real world, but it's performing a function, and you can iterate on that. You can adjust things, change things, be improving your code, adding new functionality without having to spend a ton of money at the rate change. When you're building hardware, you do. It's expensive and it's slow and it's hard, and each new idea, like we'll think something up, and some of our parts need to get be put through an $18 million machine just to like turn into parts, and that's not feasible for everyone. But software lets you push a new idea as you think it up, and we're
nothing
hoping
catches on fire. So that's good.
Thermal event. Had some thermal events.
We got flying paper here. Chris, quick question about your mecha monster. You've got guns, that's awesome, thank you so much. You've got guns, you've got shields. Can you talk a little bit about how you can customize your battle robot, your mecha monster, and how that's going to evolve?
Because I always love a good plug. So the idea is these guys, you can take bits off them, you can change how you play the game with them. But you can also then go on to the app itself and program new moves. So if you're always that guy on Counter-Strike that likes to, gloat after winning, you can do the same with this. You can start showing off. And that's basically what we wanted, is a product going back to and making it their own. And that's really one of the only ways, just with Lego, everyone builds the Lego kit. And they go, yeah, this was really cool, but now I'm going to make a giant flying shoe plane weird thing. And people start doing that, and we wanted people to be able to kind of get close to doing that without having to have any skills to take these things apart. And that's kind of what we're hoping, by letting them add new stuff, both virtual and physical.
And for you guys, you've built the arm so that it can be used for camera stuff, for various mechanical movements. Are you going to open that up for people to program? Like, how are people going to be able to use your arm?
Yeah, that's a huge part of what we're doing, is making it so I think, like Dan was starting to say earlier, that you don't have to be a hardware developer, you don't have to be a roboticist to start building robotic applications. You can build the app and not the robot itself. So yeah, we will be. I mean, we see in 3 to 5 years, it's a platform that is, in the same way that it's very, very easy to build applications for your phone, it should be that easy to build applications for a robot, and it should be that easy to download applications for a robot. And so this is a lot of the really cool technologies that are being developed right now, we see as integrating in the real world, and the software is the glue between them.
One thing we've also worked really hard on is making sure there's a really smooth ramp with skill levels. You can start out, and get automation in your home by just grabbing this robot, moving it through a rotation, and moving it through a motion, and then performing a task, and it will redo that 1,000 times perfectly. By the same time, if you learn a very basic visual programming language, you can arrange little blocks on your screen, and you can start adding logic to that. You learn a simpler, like an Arduino type embedded language, and you can program in that and get more advanced logic, internet connectivity, have it respond to some web form or a iOS application that you build. And then if you get, you have had this since high school, and now you're in college, and you know C, and you know assembly, and you know how to work things, you can integrate this to the HoloLens. We've got an incredibly powerful little computer inside this, and it's meant to interact with you at any skill level that you can approach it at.
So you guys are on the cutting edge of robotics. what's making you excited? Like, what's exciting you about the future of robotics? What's on the horizon?
It pretty much comes down to, I think, cost. When we all grew up watching robots way back, kind of 10 years for some of us when we were kids, these robots cost hundreds of millions of pounds to see these cool robots, and a lot of them were just fake and made up. But nowadays, especially with people like 3D robotics and so on, they're bringing robots down to such a cost that anyone can go out and buy them. It's the same as having a mobile phone, and it's that kind of acceptance to just go to the shop, buy one cheaply, use it, do what you want with it, and then you have a robot now. I think that's really the exciting thing, is how cheap we can make these things and how ubiquitous and put them out there, really.
I would agree with that. I would also, I'm really excited by the convergence of technologies. So I'm really excited by when you combine low-cost robotic arm or a low-cost automation system with something like, let's say, voice command, and you then get into this like Iron Man world of reality, and we aren't as many steps away as it might seem, and things really are accelerating at a kind of exciting pace. And so, I mean, with us, like, we already integrate with voice recognition. We can say, move here, and it will, and the arm will do that, and it can interact more with the world. So you're going to have, in the next 10 years, really, truly smart homes that understand, that work together, and that understand you in the way that your phone understands you. And that's cool.
What really excites me is we're on the verge of democratization. It feels, and to people who are in the industry, it really feels like we are right at, like, robotics today are where computers were in the 80s, where you're going from these huge mainframe models that could only be accessed by, afforded by enormous companies, and an individual researcher would maybe be able to book 2 hours on one and upload their program, and it runs once, and the pace of development is going very, very slowly. Then PCs come out, and it's personal. You can afford it. You can put it in your home, and maybe it's not as powerful as the mainframes. Maybe it's scaled down. Maybe it has made some compromises because it's a consumer device rather than an enterprise device. But that creates an explosion of new possibilities, new technologies, and new applications that no one could have seen coming. And we don't know what that's going to be.
Yeah,
it's
I mean,
really
like,
cool.
people ask us about the personal computer, like, oh, it's really great, it's really cool, what would it be used for? We have like that's a crazy question to us now because it's ubiquitous in our lives. I mean, we have like a $93 billion gaming industry that wouldn't be possible without computers, and when you add even more like actuation in the physical world, of course you're going to get the next gaming industry, the next like frontier.
It's exciting.
I'm excited. So this is sort of a question. Is there something you wish you knew or you'd learned before starting in robotics? I mean, your own personal up, down, down, left, right, VA start, if you will.
Saw that.
Wait, does that mean I speak?
Yeah. You just volunteered yourself.
I wish I knew.
I'll tell you what I'm glad I didn't know. I'm glad I didn't know how hard it would be.
Oh my god.
Because, and this is just, I think startups in general, if you really knew how hard it would be, you might not start.
Or like sleep.
Yeah, so just assume
time.
you'll get there in 3 months, and when you get to 3 months, just assume it's another 3 months.
I do wish I'd had more programming background. I knew you have an excellent programming background. I've been programming since I was pretty young, but the kind of, if I had gotten into that at an even earlier age, it's very much like the glue technology, and it's the intelligence that enables a lot of what we're doing, whether it's programming the robot itself or programming the tools that make the robots.
I would learn to look at the power supply before I turn it on. I think I do that every day. I just turn it on, like, oh, 50 volts, crap, and then mind. And that's probably my personal cheat in life is to do that.
Read the box first. You guys mentioned software. Is there a particular language, or is there a particular type of programming that's helpful for you guys?
This is a dangerous question to ask a group of people, because obviously
No.
it's C, but they'll say something completely different because they're mad.
Well, I mean, we're dealing with C, we're dealing with Python. I mean, we're dealing with every level of the stack so that you don't have to. What we found though is that people are most excited by well, Python is being taught now as a primary language in a lot of university programs, and Swift just went open source, and that's pretty cool. So you can see that in more connected devices. I think it's not necessarily the language as much as it is the level of the language, and when and the fact that you can be further away from zeros and ones, and that's cool.
And we program in C, so you don't have to.
Just write any language though, I think is the key to it, because you learn one, it doesn't take that long to pick up the next one, as long as you know roughly the kind of skill set needed to use programming, basically.
Yeah, I know probably maybe like 15 odd languages at this point. Maybe 8 of them I'm really good in, and 3 fluent, but that's a lot because when I was younger, instead of building new projects, I'd see a new language and like, oh, this would be perfect for my database application. A mentor once told me, and this has rung true for a very long time, the best language is the one you know.
I barely speak English, so.
But if you have a project in front of you or something you want to do, don't learn a new language for that. Build that project. Get as far as you can in what you know already, and the rest will follow.
I would agree with that.
All right, we can open it up to Q&A. If anybody's got any burning questions about robots.
Look how he's looking at me. Look right at me.
I am kind of.
I don't have a burning question, but you just looked right at. I was like, what? No.
Now all 4 of us are looking at you.
But now
We're expecting.
now you said
Now I
something. So
volunteered.
we're gonna stare intently until you say something.
They're looking at the
If
No
the whole
pressure.
room could
They're
just
looking at
stare
the loudest
in that
person.
direction.
That is definitely me. So with the way that processing has changed, how much has that helped you be able to develop the ability for robots to, deal with multitasking? I mean, obviously everything in the real world is point A, point B. You have to teach it how to open a can of Coke before it learns how to open a can of Coke. But the fact that we're looking at a 10 to the 25th processor in our lifetime, which outpowers the human brain by just a little bit, what do you think you guys are going to be able to do with that? Are you excited?
We are crazy excited, and one thing that's awesome, we are in the Qualcomm Research Center, and we get to see some technologies we're not allowed to talk about. But it's kind of odd because we have a couple different layers of processing that we use in our robots, and we have these internally labeled as this is the prefrontal cortex, this is the lizard system, because some tasks they can't be handled on the latest and greatest processors because they have to happen in real time, and they have to happen in the exact same amount of time every single time, no matter what. Because with software, a lot of programs, it's okay to kind of fudge how long it's going to take and swap memory in and out, because everything else can kind of slide to meet that. With robotics, and when you're hurling around tons of metal, you can't fudge that. The software has to run exactly in sync with the physical processes. But the absurd amount of power that we are getting on the in the higher systems, that lets us do some amazing things with vision, with recognition, voice recognition, with autonomous mapping and planning. And that's one of the reasons we think that software is going to be another big expansion front. We're trying to build a platform because we want everybody to be able to develop on top of this. And we aren't we are awesome roboticists, but we might not be the best person who knows how to make an audio system, something that will handle a specific industry that someone else knows better. And those people are going to have more power than we ever thought possible before. Excited about that.
I think that's
Good question.
Did you say you had another question there?
Does anybody else have a question for our
Don't
panel?
encourage me. Don't encourage me.
Lexi has a question.
Yeah, so Reach Robotics, you guys talk about two-player gaming experience. Is there a one-player gaming experience?
Yeah, there is a one-player gaming experience. Like all cool people, we are venturing into the world of augmented reality. So the whole idea is we can track these robots on the phone, and thanks to processing getting up to crazy speeds now, people like Qualcomm who are with Euphoria and so on, it is now possible for us to track the real world with our phones. Something my Nokia would love to do with Snake, kind of thing. And yeah, so it's a one-player game with augmented reality. It's kind of a tower defense game. We send in virtual characters, you blow them away with your real robot.
Interesting.
And that's it in a nutshell. And the whole idea with this as well is we can interact with the physical world. If you stand behind your table, the creatures can't get you through the table, kind of thing. And that's kind of bringing the living room to make it your battlefield, kind of thing.
Any other questions from the audience?
Lewis, this one.
Oh,
Two questions. One is, so as far as like just programming development, just practicing that on your own, like how do you know like you reach milestones? Like like do you have like a specific goal? You you want to try to learn networking, or like how to do like object-oriented programming. Like how do you know like you're making progress as far as the software development side of things?
Do you mean personally?
Yeah, personally, and towards robotics.
I don't think a lot of programmers ever set a goal. They say, today I'm going to learn networking. And what they do is they go, I'm going to do this, I'm going to make a program that does this. And then you go, crap, I have to actually now figure out how to do that. You start looking at how to do that. You're saying like, I need to do networking. You start kind of touching on little bits of the subjects, and the more you do it, the more confident you become. And that's generally where I don't have milestones. But normally what happens is the CEO goes, we need to do this, and I go, yeah, it's really easy. And then I look at it and go, I need to learn how to do that now. And then the milestones are kind of making a program that actually does something that you need it to do. I think the worst thing we ever did at kind of our university program is they're like, today we're going to make a program that counts how many dogs are in this picture, but it's a program that you never needed. We learned by making programs I needed really. And then by needing these programs, I was really enthused about doing it, and that was the milestone of finishing the program. Whatever I learned in there was a bonus, basically, of finishing the program, because otherwise you learn things that you really don't need to learn if you just kind of went, I need to learn about all of networking, when really I just wanted to send a packet to another computer. It's best to go, well, I just need to send a packet, I'll just look at that, and then other things will come from there, really, for me. I don't know about you guys.
Yeah, I would say that the proof is really in the pudding in that sense, in that does it work the way you anticipated? Is it breaking less, or is it breaking in different ways? And you sort of gradually get there. But the interesting thing with programming is that as you get better at things, you spend less time on the things that you already know. So you're kind of always running into walls. It's just you're running into different walls, which is exciting for some people, I guess. Probably not for a lot of people, but exciting for some people, because the more that you understand how to solve the problem, you've probably already automated a way to do it. So that's not what you're going to be spending.
With copy and paste, really. Once it works, I'm just going to take this from here. Now that is the true thing with programming. You're always learning new things, because once you've done the old thing, you can just use it again.
Yeah, know it. You have it.
And one thing I would add on to what you were saying earlier, the biggest milestones that I've had, and one thing that took me a long time to kind of get a hold of, was just finishing projects. And when you start building things, when you start programming or building things in a workshop, you'll have a great idea, and you start running at it, and then you start to get less interested as it gets more and more difficult. And I had this huge graveyard of half-finished projects, and the amount that I learned from those was very, very small compared to the few things when I was like, I'm gonna finish this whatever it takes. And even for smaller things, even when I kind of lost interest in it, part of that is because you have to push through barriers. You have to push through things that you don't know and build up those new skills. So every time I've actually been able to finish a project, that's been a huge milestone for me.
And it's always that last 20% that makes you, that takes the most time, that is the hardest, and actually makes you the best programmer.
And so another one is, for your works in robotics, do you folks utilize a lot of 3D printing? If so, for prototyping and stuff, and if so, just something like that?
I think that's probably one of the biggest things that's pushed on the industry, especially for small people like us when we're starting out, is everything is 3D printed. Our whole robot, apart from the screws on there, are 3D printed. We have our own 3D printer. A lot of the places we go to have their printers. But people like Shapeway, Incept 3D, for £7 you can send them a design, they can send you back, half this. Well, this doesn't cost for about £70, so $100 convert to your funny money.
About right.
You can get a whole robot kit sent back to you. It just takes your time and effort to design it, or go somewhere like Thingiverse and someone would have already designed it for you and shared these kind of things. And I think with 3D printers, it's apart from their actual ability to lay things out on there, you can do a hell of a lot of stuff that we couldn't do 5 years ago without being, NASA and all that kind of stuff. And now we can do it, with PLA in our bedroom kind of thing.
Yeah, I would say it depends a lot on the quality of your printer. And also exactly what you are doing. If you're looking at maybe housing it, or something that's very structural, then that's great. If you're looking at some kind of precision part, you're not necessarily going to get. We deal with a lot of precision parts in order to get to have a precise robot, you need to have precision parts. And so for us, it's kind of. It's definitely enabled us to do more and to demonstrate to other people, because a lot of people don't necessarily want to see the internals, they want to see the shiny plastic. But there's still, we're still using a lot of other technologies, a lot more.
I would agree with that. Everything we do is largely CNC or EDM or a couple other processes. But that said, we've derived an enormous amount of value from 3D printing because it's fast, because we don't have to deal with someone else, because we can think up a shape and print it out. Or for parts that don't need to be very precise or don't need to be very strong, we can, in little support jigs and test fixtures, we can pop, 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 and it comes out. I had a bit of a bias against 3D printing for a while because I thought it encouraged some bad design practices, because there's no limitations. You can just build any shape, but that doesn't scale. There's a lot of shapes you can't make in production. But that said, if you build a 3D printer, you are going to learn a ton about software, a ton about mechanics and electromechanical systems. If you have a 3D printer and you can work with CAD and start spitting out designs, you're going to learn a ton about design and what makes a product strong, what shapes work with movement. And those lay incredibly valuable foundations to converting that to, a product that can then scale to hundreds of thousands of units. Thank you.
Awesome questions. Anybody else? Another question? Somebody's got a question.
Means I get to go home early. This is great.
I got a question. More likely, Z-Day or AI-led robot apocalypse?
So, I'm personally, I think the AI-led apocalypse, only because computers are moving so quickly. They already make decisions every day for us. They pester us every single day. The phone rings and it's an automated teller, and that was a decision by a robot to go, hey, this guy needs to be called right now because you'll be on the phone to him in 2 seconds, but you're too busy talking to someone else and you never get back to them. And that's why we all sit there listening to an empty phone kind of call. And they're only going to keep getting further and further on, and the more we try and control them, the less kind of control we'll probably have if we want them to do cool and exciting things. So yeah, as much as I'd love the zombie apocalypse, but AI apocalypse is coming.
I'm going to go with zombies.
Yeah, as a AI developer, I'm also going to go with zombie apocalypse. I
smell some bias.
Well, I think a lot of it comes down to power, because you can. If you have a mobile platforms are limited by battery technology, which we haven't made significant advancements with in the last 20 years. Things are going to eventually. You build the best killer robot, worst killer robot. I don't know.
We agreed we
The
weren't going to
most
say
killer
robot.
Oh yeah. No.
So
It's going to run out of power. It's going to shut down. If there's a biological weapon source, we're filled with carbon. We're made of carbon. Carbon.
This was so I've come from a university background, as a lot of my industry, and we had to sit down one day, honestly, with some kind of suits from outside the department, and they were like, "Oh, what's some of your biggest concerns for your department?" They were talking about health and safety of the department, and I offhandedly joked that I was really afraid one day that not about the robot uprising, but some mad person like Sarah Connor would turn up and start shooting their way through the building. And I thought it was a joke. I thought everyone had seen Terminator. I knew I was joking. And this guy sitting opposite me, in his suit, never done robotics or anything, just stared at me and went, "Is that a serious thing?" And I was like, "Shotguns do exist, and there are crazy people in the world." And he kind of laughed like it was an offhand thing. He was like, "Oh yeah, you academics alike." And then about 3 weeks later, I got an email from him basically asking my opinions about if people really were going to come to the lab and start shooting us. And I honestly thought he was joking, and then so I ignored the email. And then like every day for like a week, he would be like, "No, is this a serious thing? Because we need to review this in our thing." And
We need to go over safety procedures.
I learned that I should never joke in engineering because apparently we don't make jokes. So yes, I changed my answer. Zombies.
Zombies.
Definitely
All the way.
no Sarah Connor's coming to kill us all.
There is no threat from AI.
For the record, then the
Less
answer
concerned
is
about AI, more
zombies.
concerned about people afraid of AI.
But there seems to be this recurring theme that robot technology and stuff is gonna change our daily lives. And can you guys touch on like how you're seeing these things change our daily lives, and what you see on the horizon here?
Robots in the home is a difficult one because we're stuck between two things of people accepting the robots. My mum loved the robot vacuum cleaner she had for a while, but not because it cleaned the house very well. She thought it was absolutely crap. She just liked it when it got stuck behind the sofa because she thought that was hilarious, and she'd go and fetch it back out again. So it's people accepting it in our homes, but it's also kind of, we need to make legal changes to allow robots, and as soon as we kind of accept that robots can live in our homes and we can have these things, that is when things are going to start changing. And when we're suddenly allowed to have these robots and we're allowed to have them look after our nan and stuff like this, that's the kind of true robot uprising. Wasn't really answering your question, but it's just we need to change laws and opinions more than, oh, they're cute and funny, more to we can seriously use these to do jobs that we took away from people like in the factories. We can do it in other places, and it can open us up to do more and fun things. Kind of roundabout.
Well, and how far out do you want to go? Because I see robotics as an enormous source of good, an enormous source of not just good, but eliminating kind of the crap aspects of the human condition. So like, take self-driving cars. If we all moved to self-driving cars, the roads would be less congested. There would be no accidents ever.
Especially here in America, you guys are scary drivers. Really scary. If the person
driving on the
behind
correct
me
side of the
can't
road.
read my dashboards, then they're too far away, it seems, here in America, which I, for one, can't wait for robotic cars to save us.
But I see eventually robotics leading to the end of tedium, of the tasks that we don't want to be doing, of the kind of repetitive things or stuff that like in our lives, even if it's not like physical labor, there's tons of stuff that we need to do that just needs doing and we hate it. Doing taxes, this is a dead weight loss in all of our lives, and just okay, now I have to like account for everything and blah, 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 blah. And each innovation in robotics strips away one more layer of this tedium until I'm hoping we live in some post-scarcity Star Trek utopia, where we can just all be artists and scientists and play games.
That's a really good point, that when we think about, it's really cool because this year you can 3D print, and 3 years from now you can download apps and voice recognition. But we think 10 years from now and beyond, it's very important to us that no one was born to work in a factory, and there are so many jobs out there that are really just terrible jobs, and if we can get to a point where you don't have to do that as your only way to make a living, I think that's a much better society. We are humans a lot of times doing robot work.
The biggest problem though with replacing all the jobs in a factory is we as humans are also bloody good at what we do. and making robots to do that is crazy complex. So we're still a little way away from replicating.
Well, there's a range,
humans,
right?
but
There's
yeah.
a range of, and there's, you know.
But once we start being able to tackle that, what a person could do with their hands, then we'll be kind of seeing robots take over a lot more jobs from people. Not in a bad way, in a kind of good way for a lot of things.
Question.
I'm not trying to criticize, but I did have a question. You were mentioning that it would be nice to create robots to take jobs that nobody wants to do. Now, seeing the current economic state that we're in, jobs being so tight, what happens when we get to like an era, say like iRobot, or one of the problems with robots taking jobs from people?
So one of the biggest arguments for this is automation isn't a new thing. And some of our biggest economic shifts where, you know, countries suddenly step up a gear and some become more prosperous and the life expectancy and the kind of general living standards improved is when a massive automation kind of process comes out. So the original one was the kind of Luddites hating combine harvesters and all these kind of things, saying they're taking jobs from us and so on. When we could suddenly do, you know, we could harvest a field of corn in a day compared to 2 weeks with 40 people, we suddenly now had the resources to provide for more people and to move things on again from there. So I don't think we should ever be worried that robots are taking people's jobs. It's robots are not freeing people up, robots are bringing the cost down on certain things. Our cars wouldn't cost what they cost today if it still required so many people hand welding with our poor joints. And by making, I think I heard on the radio that you get a car here for $110 per month, and that's only possible with robots. And now I'm allowing someone who is on a low income to get a car to go travel, maybe travel to get an education, travel to get a job. Where without robots, they wouldn't be able to have that car, so they'd have to work next door, they'd have to get the bus, and you know, these things start taking away from the human condition when we have to do all these things that can be made better by robots. Yeah, we can get to the dangerous stage where all our jobs are replaced by robots and we spend our days just watching robots watch other robots and no one has a job. If we ever got to that stage in life, then everyone is fed, clothed and looked after, and I still think we're extremely long way from that really. But we shouldn't stop automation. It's been going on for hundreds of years and it's generally only seen as an improvement to society, but there is always that worry, that we'll watch robots watching robots. And
the prospect of getting to a point where everyone is fed, clothed, and housed is one of the things that I think is really exciting about robotics, because I think that's one of the few ways we can actually make that happen. Robotic labor is free, and if we can have power generated by robots, if we can have food grown by robots, if we can have housing built by robots, everybody can be provided for. There are some studies by like Accenture forecasting that over the next 10 years there's going to be I think $3 trillion increase in the economy, like the global economy, from the introduction of robots, and then I think it's 2.2 million net increase in jobs, because there will be jobs gone that robots are then doing. But there'll be more jobs created as people have to program the robots and start building new applications for the robots, and as the robots themselves open up new industries. So the hope is that it's a net gain, and that's one thing that
That's
we're
the
all
history
really
of our
looking for.
Civilization, is finding those jobs and creating them. I mean, there was no such thing as a software developer, until like a few years ago. In some people's lifetime.
That adds to it as well, that when computers originally came out, they were like, great, this is the end of everyone having to do any work, computers will take over all the work for us. And then it turned out, no, they were just another tool for people to do more work. And I think most people nowadays spend most of their time at work sitting in front of a computer doing work. And that was it. It's another way to move on what we do, kind of thing.
Well, so there you have it. Robot-led utopia. We've taken care of everything today. Really want to thank everybody for coming out today, sitting on this panel, asking some great questions. Again, Reach Robotics, Carbon, we will be here for a couple minutes. Come on up, ask questions, say hi. Thanks again.